And then in the last video, we talked about how transactions work in a monolithic app. One place, one database, and asset keeping everything in check. But in microservices, things change. One transaction can touch multiple services, each with its own database, and without the Saga pattern, things can get messy real quick. So in this video, part 2 of our Saga design pattern series, we'll break down the key challenges you'll face if you don't use Saga in a distributed system. By the end, you'll see exactly why that old monolithic style transaction just doesn't work in the microservices world. Well, imagine you have got a big business process that touches multiple microservices, like placing an order, reserving inventory, and processing payment. In a monolithic app, this would be one nice big transaction, but in microservices, each service has its own database. So doing one big transaction across them is just not possible. That's exactly where Saga comes in. Saga basically breaks that big process into smaller local transactions, each handled by a different service. Once one service finishes its part, it either publishes an event or calls the next service in the chain. And here's the best part: if something goes wrong at any step, the whole system doesn't just fall apart. Instead, it runs compensating transactions, kind of like pressing undo step by step to reverse whatever was already done. So in short, Saga helps microservices keep their data consistent without using those heavy, complex distributed transactions. So that was all about the definition of the Saga pattern. And before we jump into the Saga design pattern styles like orchestration or choreography, which are basically the two ways Saga works, first let's talk about something important: the key challenges you will face if you don't implement Saga in a microservices system. Because knowing the problem first makes it way easier to understand the solution actions. Before we jump into the Saga design pattern, let's first talk about what were the key challenges in microservices without Saga. So here's a simple scenario. First, the order service creates a brand new order in its own database, and then it calls the payment service. The payment service happily deducts the payment, and then it calls the inventory service to reserve the stock. But suddenly, the inventory service fails. Maybe the item's out of stock, maybe there's a system error, whatever the reason, the reservation doesn't happen. Now here's the problem: the order is already created and the payment is already deducted, but stock couldn't be reserved. Without Saga, there's no easy way to roll back all those previous steps across multiple services. And now we've got a serious problem. The order was created, the customer was charged, but the inventory step failed. So basically the user just paid for something that can't even be delivered. This leaves our system in a totally inconsistent state. The order can't be fulfilled, the user's money is gone, but no product is on the way, and the whole system's data is now out of sync. This is exactly the nightmare scenario we want to avoid. The customer's now frustrated, really frustrated. Your support team completely swamped with refund requests. And the worst part, users start losing trust in your system. Angry customer, support team stuck handling refunds manually, and slowly your reputation takes a hit. So why does this actually happen technically? Well, in microservices, each service has its own database, totally separate. There's no big global transaction holding everything together. So if one step fails, there's no built-in way to roll back what already happened. Each service is just doing its own thing, acting in isolation with zero coordination, no shared transaction across services, no rollback logic on failure, services acting in isolation. Alright,